we're going to talk about this big idea that's called the mean value theorem. Now, as far as mean value theorem goes, just going to set the stage. For the most part, what we do with the mean value theorem is incredibly basic and almost worthless. So when I talk about the mean value theorem and we do an example, we do the typical example, I don't want you to think, you might think, okay, how is this a big deal? It's not very, for what we're using, it's not a big deal at all. What I am going to tell you is that the mean value theorem has giant implications in math classes after calculus, right? It does a whole lot it doesn't do that much for us in this calculus course. It does a lot in upper level math. All right? So college professors understand how important mean value theorem is, right? So since it's important in upper level math, we present it in your first course in calculus, right? And since college professors write your textbook, they make sure that it's included in your calculus book, right? So there's lots of things I talk about, and it's like, oh, you can see where it fits in. This is not one of those. All right, so that being said, instead of actually stating the mean value theorem, I'm going to draw a picture, right? All right, because the actual theorem, I don't think it makes more sense when we have a picture. And so here's the picture. My picture is I'm going to create a function, right? It's going to be a nice function, and I'll talk about what nice is in just a little bit. So here's A, here's B, and if this is my function f, we okay, this is the coordinate A, comma, f of A, and this is the coordinate B, comma, f of B. Mm-hmm. Everybody okay with that? So we have a nice function that goes from A to B, and there we go. Now, here's the situation. If I ask for the mean of something in math, what does the mean of something mean? Average, right? So when I talk about mean value theorem, there's some averaging, okay? Well, what are we averaging? Well, at this point, we're averaging slopes, because that's what pretty much slope of the tangent line. Now, I want you to kind of imagine, can we see that the slope of the tangent line here is kind of steep? Mm-hmm. And as I move along, the slope of the tangent line is kind of shallow. Mm-hmm. If I wanted the average slope, right? Like I could add all these up. Does it make sense that the average slope of the tangent line is if I connected these two dots? Mm-hmm. Does that part make sense? Now, just for fun, because this is not a calculus question, how do we find the slope of that green line?
Y, what's that supposed to be?
That's the line. I want the slope. Yes?
F of B minus F of A over B minus F.
Perfect. Right? Y minus Y over X minus X. Everybody okay with that? So I'm going to write that down. That's kind of a big deal. So I'm going to say F of B minus F of A all over B minus A. Are we okay that this is not calculus? All this is finding the slope. Granted, a little more complicated than what you did in Algebra 2, but you're still just finding the slope. Everybody okay with that part? Okay, now, here's the calculus part. The calculus part says, if f is nice, and I'll talk about what f being nice is in just a little bit. If f is nice, then there is a magic value c so that the slope of the tangent line is the same as the average slope. And let's let that sink in for a little bit. Does that make sense? Okay, if the function's nice, all right, nice means nice and smooth, all right, there has to be at least one spot where the slope of the tangent line is the exact same as the average slope. Now, let's talk about that with calculus. Slope of the tangent line, that's the derivative at a certain value. And so my derivative, so f prime at that magic value c, this is the calculus part. And I'm going to put an equal sign in between. And I just tell this is the equation that's associated with the mean value theorem. And what the mean value theorem says is, if you have a nice function, okay, then there's got to be at least one spot, one x value, such that the slope of the tangent line is the same as the average slope. Does everybody see how that works? Okay, now here are the words that go with that. Mathematically, I can't just say, is f nice? F is nice. So the way we say f is nice is we say if f is continuous on this interval a, b, and differentiable on the open interval a, b, then there exists I've always put it in quotes, C in the interval a, b, so that this equation happens. You don't have to write this down. It's in every book, virtually like this. Or you can look it up. There's no point. Pretty much if I were going to copy anything down from this, I would draw the picture and I would draw the little formula. And that is your mean value theorem. Right? Does everybody have a picture for mean value theorem? Right? You find this mean value theorem says if you have a nice function, there has to be a place where the slope of the tangent line equals the average slope. That's what it says. Right? So, what do you do with it? Well, here's what we do with it. It's kind of silly. We have a bunch of problems where you have to find the magic x value, the magic c value. Right? So how do we do that? Well, here's what it looks like. I give you a function. Let's say f of x is equal to x squared plus 1, and I give you an interval. I always like -1 to 2. So there's I give you a function and I give you an interval, and you are asked to find this value of c where the slope of the tangent line is the same as the average slope. So what do? Well, let's find the average slope. The average slope is going to be f of 2 minus f of -1 all over 2 minus -1. Don't worry, I'm going to draw a picture. You usually don't draw a picture with this, but I'm going to draw a picture with this one after we're done with it. Okay, so what do I get? Well, f of 2 is, what's that, 5 minus 2 over 3. Are we okay that our average slope is 1? If I compute that, I get a 1. I get 3 over 3, which is 1. And now I'm going to do the calculus part. So the calculus part says, well, I got to take the derivative. And so the derivative of this is going to give me 2x. So that's f prime of x. When I take the derivative, I get 2x. Now, I need to talk for a little bit about what derivatives mean. When you take a derivative, it represents a formula for the slope of the tangent line. Okay? So everybody okay, the derivative of fx is 2x? That part's easy, right? So our derivative, it's a formula, meaning you give me an x value, I'll tell you what the slope is. Like if I want the slope to be, if I want to know what's the slope at 7, I plug a 7 in and I know what the slope is. The backwards way to use this formula is you say, if I tell you what I want the slope to be, you can tell me where that happens. What do I want the slope to be? 1. Now, if I want to find out where that happens, I take the derivative and set it equal to what I want the slope to be. Since I want the slope to be 1, that's going to happen at x equals 1/2, if I solve for that.
So 1/2 is c?
So 1/2 is that magic c value, right? And so I just found out, in this case, that c is equal to 1/2. But I want y'all to see a picture. You don't always get a nice picture, but we can with this. So for this one, okay, so here's -1, here's 2. Is everybody okay? That's our graph. That's our picture. Now, the green line is just the average slope, okay? Like if you connect your endpoints, that's the green line. And our slope of the tangent line, what we just found out, at x equals 1/2, so here's 1/2, the slope of the tangent line is the same as the average slope. So we're looking for, there's our C, we're looking for that one spot on our graph where the slope of the tangent line is the same as the average slope. Well, or a spot, it's not always one spot. Yes?
So what do we use this for?
I told you.
Nothing?
This is not very useful. So the mean value theorem at this level is not very helpful. So it's basically, we're basically sort of forced to find the C. Right? How is that useful in the big picture of anything? Not really. Yes?
So would we have to do anything with this, or any sort of question would just be to find it?
Well, good question. For many, many years on the AP exam, the worst they would ever ask you to do is find the C. In recent years, they have figured out clever ways to make you use it, and so I'm going to start showing some of those in a little bit. But right now, it's all about finding the C. All right, so let's try another one. So let's say I give you f of x is equal to x cubed, but this time I'm interested in the interval from -1 to 1. Value of c, okay? So the first thing I want to do f of 2 minus f of -2 all over 2 minus -2. Let's see, that's 8. Minus -8 over 2 minus -2. 16 over 4. Everybody get a slope of 4? So our average slope is 4, yay, right? And then when I take the derivative, let's see, f prime of x is equal to 3x squared. And so I end up with 3x squared equals 4. And when I solve, I end up with x squared is equal to 4 over 3. Or that x is equal to 2 over the square root of 3, plus or minus. So how many values of c did we find?
2.
We found 2 values of c. Here's why. If you look at your picture, we have this x cubed graph that does that, right? If I draw my average slope, can you see there are 2 places where the slope of the tangent line is the same as the average slope? So sometimes you can find multiple values of c. Now, as far as your homework goes, I gave you 2 Khan Academy assignments. One Khan Academy assignment is effectively this. I give you a function, I give you an interval, and your job is to, I'm not done teaching yet, so you wait just a minute. Okay. I give you a function, I give you an interval, and your job is to find the magic c value. So basically, use the interval in the function to find your slope, then take the derivative, set it equal to, and solve for x. And then you find the magic value where the slope of the tangent line is equal to the average slope. And are there multiple choice questions like that on the AP exam? Yes. Every once in a while those show up. Right? There's a better question. And this is what they started doing recently. What they started doing recently is giving you a chart. Right? And this is what the chart looks like. The chart looks like they give you an x value, and they'll give you a function. They usually call it f of x or g of x or something like that. They love charts. So I'm going to pick some values for x. I'll pick 2, 3, 5, 7, actually 8. Or how about a marker that writes? Okay, so let's see. 2, 3, 5, and 8. And -1, 4, 3, and 2. All right. And the question they ask